98 million years ago, a new predator emerged. It wasn't the biggest, but it was one of the most brutal. This is the story of Madtsoiidae, the snake family that outlived the dinosaurs and terrorized the ancient world for nearly 100 million years. The Madtsoiidae were a remarkable group of snakes that dominated ecosystems across continents for an astonishing span of time. While many associate prehistoric giant snakes with Titanoboa, the truth is far more complex. Titanoboa, despite its impressive size, was primarily a fish eater. The Madtsoiidae, on the other hand, were terrestrial hunters with a diverse and gruesome diet. These ancient serpents possessed unique adaptations that set them apart from their modern relatives. Their primitive skull structure, once thought to be a disadvantage, actually allowed them to employ hunting techniques that would make even the most formidable predators shudder. As we journey into the lesser-known world of these formidable predators, prepare to discover why the Madtsoiidae were truly the masters of their time. As formidable as the Madtsoiidae were, their story began with a single bone. From this humble fragment, scientists uncovered a family of snakes so diverse and adaptable that they would dominate ecosystems for nearly 100 million years. What made these serpents so extraordinary? And how did they achieve such long-lasting success? The origins of the Madtsoiidae family can be traced back to Africa, where a single bone discovered in Sudan provided the first clue to their existence. This discovery opened a window into a world where these ancient snakes reigned supreme, predating even the ancestors of the infamous Titanoboa. As researchers delved deeper into the fossil record, they uncovered a remarkable diversity within this family, with 17 distinct species known to science today. The Madtsoiidae evolved during the Cretaceous period, approximately 98 million years ago. This was a time of great change and competition in the animal kingdom, with dinosaurs dominating terrestrial ecosystems. Yet these snakes managed to carve out their own niche, adapting to a wide range of habitats and prey types. One of the most striking features of the Madtsoiidae was their impressive size range. While some species were relatively modest, measuring around 2.6 feet, 0.8 meters in length, others grew to truly formidable proportions, exceeding 11 feet, 3.5 meters. This diversity in size allowed the Madtsoiidae to occupy various ecological niches, from small prey specialists to apex predators capable of taking down large animals. The success of the Madtsoiidae can be attributed, in part, to their unique hunting techniques. Unlike modern snakes, which typically swallow their prey whole, the Madtsoiidae employed a far more brutal approach. Their primitive skull structure, once thought to be a disadvantage, actually allowed them to tear their prey apart before consumption. This method of feeding set them apart from other prehistoric snakes like Titanoboa, which primarily subsisted on a diet of fish. The ability of Madtsoiidae to adapt their hunting techniques was crucial to their survival in a world dominated by dinosaurs and other fearsome predators. By developing specialized methods for subduing and consuming a wide variety of prey, these snakes were able to thrive in environments where competition for resources was fierce. In contrast to Titanoboa, which was largely confined to aquatic environments, the Madtsoiidae were terrestrial hunters. This allowed them to exploit a broader range of food sources and habitats, contributing to their long-term success. While Titanoboa may have been impressive in size, the Madtsoiidae were arguably more versatile and adaptable predators. The evolutionary journey of the Madtsoiidae is a testament to the power of adaptation and specialization. From their humble beginnings in Africa, these snakes spread across continents, diversifying into a range of species that could survive in various ecosystems. Their ability to adapt to changing environments and prey availability allowed them to persist through major geological and climatic shifts that spelled doom for many other species. While the Madtsoiidae's adaptability was remarkable, their true claim to fame lay in their unexpected role as dinosaur hunters. Picture a world where snakes preyed on some of the largest creatures to ever walk the earth. What gave these serpents the edge over their colossal prey? Enter Sona, a member of the Madtsoiidae family that lived during the late Cretaceous period. This ancient snake wasn't just content with small game, it had a taste for dinosaurs. Fossil evidence suggests that Sona consumed newly hatched titanosaurs, some of the largest dinosaurs to have ever existed. This discovery paints a vivid picture of a world where even the offspring of giants weren't safe from these formidable predators. The hunting prowess of the Madtsoiidae can be attributed in part to their unique skull structure. Unlike modern snakes, which have highly flexible skulls allowing them to swallow prey whole, the Madtsoiidae had a more primitive, less flexible skull. This might seem like a disadvantage at first glance, but it actually gave these snakes a terrifying edge in their predatory behavior. Their less flexible skulls meant that Madtsoiidae couldn't simply swallow their prey whole. Instead, they developed a more brutal feeding method. These snakes would use their powerful jaws to tear their prey apart before consumption. This gruesome technique allowed them to tackle larger prey items that would have been impossible for them to swallow whole, including young dinosaurs. However, the Madtsoiidae's most impressive feat was yet to come. As the age of dinosaurs drew to a close, these ancient snakes faced their ultimate test, the Cretaceous-Paleogene extinction event, also known as the KT extinction. This cataclysmic event wiped out approximately 75% of plant and animal species on Earth, including all non-avian dinosaurs. Yet, against all odds, some members of the Madtsoiidae family survived. One such survivor was Madtsoia, a later and larger species of Madtsoiidae. Fossil evidence shows that Madtsoia persisted through the KT extinction, making it one of the few known genera to survive this mass extinction event. But how did these snakes manage to endure when even the mighty dinosaurs perished? The secret to Madtsoia's survival lay in a combination of unique adaptations. First, their low profile allowed them to find shelter in hard-to-reach areas, protecting them from the immediate effects of the extinction event. Whether it was burrowing underground or hiding in small crevices, these snakes could escape the worst of the environmental changes that spelled doom for larger animals. Second, Madtsoia possessed a remarkably slow metabolism. This adaptation allowed them to go without food for extended periods, potentially up to a year. In a post-extinction world where food sources were scarce and unpredictable, this ability to survive long periods of famine gave Madtsoia a crucial edge over other predators. The survival of Madtsoia through the KT extinction is a testament to the resilience and adaptability of the Madtsoiidae family. These snakes had already proven their ability to thrive in a world dominated by dinosaurs, and now they demonstrated their capacity to endure even when those dinosaurs disappeared. This remarkable survival story challenges our understanding of prehistoric ecosystems and the factors that determine which species persist through mass extinctions. The Madtsoiidae's success story isn't just about size or strength, it's about adaptability, resourcefulness, and the ability to exploit ecological niches that other predators couldn't. The Madtsoiidae's evolutionary journey took an unexpected turn after the mass extinction. In a world devoid of dinosaurs, these snakes didn't just persist, they thrived, but at what cost to their prey? Picture a snake so massive it was initially mistaken for a crocodile. What could have driven such extraordinary growth, and what did it mean for the ecosystems it dominated? As the dust settled from the cataclysmic events that wiped out the dinosaurs, the Madtsoiidae found themselves in a world ripe with opportunity. These ancient serpents, having survived where so many others perished, were poised to take full advantage of their newfound dominance. During the Eocene epoch, approximately 56 to 33.9 million years ago, members of the Madtsoiidae family, such as Madtsoia, began to expand their territory, slithering their way into South America. Here they would grow to truly astounding proportions, reaching lengths of up to 33 feet. However, it was in the murky swamps of ancient Europe that the Madtsoiidae would reach their pinnacle of size and terror. Enter Vukindicus, the largest known member of the Madtsoiidae family. This behemoth of the serpent world is estimated to have grown between 40 to 50 feet long and weighed around 1 ton. To put this into perspective, Vukindicus was longer than a school bus and heavier than some cars. Its sheer size was so impressive that when its fossils were first discovered, they were mistaken for those of a large crocodilian. Vukindicus was primarily a terrestrial creature, but it had adapted to hunt in the treacherous terrain of swamps and marshlands. Its hunting strategy was one of patience and ambush. Picture a colossal serpent, perfectly camouflaged among the reeds and murky waters, waiting for unsuspecting prey to stumble into its domain. When the moment was right, Vukindicus would strike with lightning speed and overwhelming force. The diet of Vukindicus was as varied as it was voracious. Its massive size allowed it to prey on a wide range of animals, including various crocodilians and turtles. Some paleontologists even speculate that Vukindicus may have been capable of taking down primitive whales that ventured too close to shore. This diverse diet showcased Vukindicus's status as an apex predator, capable of dominating virtually any ecosystem it inhabited. For millions of years, Vukindicus maintained its position at the top of the food chain. Its size and hunting prowess made it a formidable predator, while its ability to adapt to changing environments ensured its long-term survival. However, even this mighty serpent was not immune to the relentless march of time and climate change. Eventually, shifts in the global climate led to changes in the ecosystems that Vukindicus relied upon, ultimately leading to its extinction. The story of Vukindicus and its Madtsoiidae relatives challenges our perceptions of prehistoric predators. While Titanoboa often captures the public imagination as the ultimate prehistoric snake, the Madtsoiidae family presents a more complex and perhaps more terrifying reality. These were not just giant snakes. They were highly adapted predators that dominated terrestrial ecosystems for millions of years. The success of the Madtsoiidae, and Vukindicus in particular, demonstrates the incredible adaptability of these ancient serpents. From surviving the mass extinction that claimed the dinosaurs to evolving into some of the largest terrestrial predators of their time, these snakes showcased an evolutionary resilience that is truly awe-inspiring. While the Madtsoiidae conquered continents, their final stronghold would prove to be their most challenging. As Australia drifted into isolation, how did these ancient serpents adapt to a land of marsupials and extreme climates? The answer lies in a tale of two snakes, where size wasn't everything, and survival meant embracing the unexpected. The Australian chapter of the Madtsoiidae saga began during the late Oligocene epoch, approximately 23 million years ago. As the continent became increasingly isolated, two distinct species emerged to dominate the landscape: Ulungar and Wabi. These formidable predators would face unique challenges in a land teeming with marsupials and other distinctive fauna. Ulungar, the larger of the two, was a true giant among snakes. Measuring around 6 meters, 20 feet in length, it retained the brutal feeding habits of its ancestors. With its inflexible jaws, Ulungar continued the Madtsoiidae tradition of tearing prey apart before consumption. This massive serpent likely preyed on a variety of animals, from large marsupials to reptiles, maintaining its position as a top predator in the evolving Australian ecosystem. On the other hand, Wabi, while still impressive at a maximum length of 6 meters, 20 feet, was relatively smaller than its cousin. This size difference, however, would prove to be a crucial advantage in the long run. As climate conditions in Australia began to shift, becoming colder and drier, Wabi's more modest proportions allowed it to adapt more readily to the changing environment. The contrasting fates of these two species highlight the complex interplay between size, adaptability, and survival. Ulungar, despite its imposing presence, found itself increasingly challenged by the changing climate. Unable to sustain its massive size in the face of dwindling resources, Ulungar eventually succumbed to extinction around 11.6 million years ago. This event marked a significant turning point in the Australian Madtsoiidae lineage, leaving Wabi as the sole representative of this once dominant family on the continent. Wabi's survival showcased the remarkable adaptability that had been a hallmark of the Madtsoiidae throughout their evolutionary history. As conditions became less favorable for its larger relative, Wabi thrived in cooler, wetter regions. This ability to adapt to diverse habitats allowed Wabi to persist for over 10 million years after Ulungar's extinction, a testament to its resilience and evolutionary flexibility. Fossil evidence provides intriguing insights into Wabi's preferred hunting grounds and strategies. These ancient snakes seem to favor areas near waterholes, using these locations as ideal ambush sites for unsuspecting prey. This behavioral adaptation allowed Wabi to maximize its hunting success while minimizing energy expenditure, a crucial strategy in an environment where resources could be scarce and unpredictable. Despite its more modest size compared to some of its ancestors, Wabi remained a formidable predator in the Australian ecosystem. The snake coexisted with an array of impressive megafauna, including giant birds, car-sized wombats, and marsupial lions. Yet, even among these imposing creatures, wabi held its own as one of Australia's top predators, until its eventual extinction. The longevity of wabi's reign is truly remarkable. This species persisted for nearly 23 million years, a span of time that dwarfs many other prehistoric predators. To put this into perspective, wabi's tenure on Earth was more than 4 times longer than the entire existence of the human species. This extended survival is a powerful testament to the efficiency and adaptability of the Madtsoiidae family as a whole. Despite their adaptability, the Madtsoiidae couldn't escape the inevitable march of time and change. As wabi disappeared from the fossil record a mere 12,000 years ago, it left behind a mystery. What finally brought an end to this incredible lineage of snakes that had survived for so long? The extinction of wabi around 12,000 years ago marked the end of the Madtsoiidae family, concluding a remarkable 100 million year reign. This ancient snake had outlasted its larger relative, Ulungar, by over 10 million years, showcasing its ability to adapt to changing environmental conditions. However, even wabi's resilience wasn't enough to withstand the challenges of a rapidly changing world at the end of the Pleistocene epoch. One intriguing theory links wabi's extinction to the arrival of Aboriginal peoples in Australia. This hypothesis suggests that human activity, including hunting and habitat modification, may have played a role in the demise of these ancient serpents. While direct evidence of human predation on wabi is lacking, the timing of their disappearance coincides with significant changes in Australia's ecosystems associated with human arrival. The adaptability and resilience of the Madtsoiidae family throughout their long history is truly remarkable. These snakes survived multiple mass extinction events, including the catastrophic end Cretaceous event that wiped out the non-avian dinosaurs. Their success can be attributed to several key factors that allowed them to thrive in diverse environments and adapt to changing conditions. One crucial aspect of their survival was their varied diet and hunting strategies. Unlike some specialized predators, the Madtsoiidae were capable of preying on a wide range of animals, from small reptiles to large mammals. This dietary flexibility allowed them to adapt to changes in prey availability and ecosystem composition over millions of years. The Madtsoiidae's unique skull structure, once thought to be a disadvantage, proved to be a valuable asset in their long-term survival. Their less flexible jaws enabled them to employ a brutal feeding technique, tearing apart prey before consumption. This adaptation allowed them to tackle larger prey items and exploit food sources that other predators couldn't access. Another key factor in their longevity was their ability to adapt to different habitats. From the swampy environments of ancient Europe to the varied landscapes of Australia, Madtsoiidae species demonstrated remarkable ecological plasticity. This adaptability allowed them to survive and thrive as continents shifted and climates changed over millions of years. The Madtsoiidae's success was also due to their ability to fill various ecological niches. While some species grew to enormous sizes, others remained relatively small. This diversity in size and form allowed the family to occupy different roles within ecosystems, from small prey specialists to apex predators. Despite their impressive adaptability, the Madtsoiidae couldn't withstand the combined pressures of a changing climate and potential human impact at the end of the Pleistocene. The extinction of wabi marked the end of a lineage that had persisted for an astounding 100 million years, outlasting countless other species and surviving through some of the most tumultuous periods in Earth's history. The Madtsoiidae's journey through time is a testament to the power of adaptation and resilience. From their emergence 98 million years ago to their final extinction just 12,000 years past, their story offers invaluable insights into evolutionary processes and the importance of adaptability in survival. Studying the Madtsoiidae provides a window into prehistoric ecosystems and the dynamics of predator-prey relationships. Their ability to thrive in various climates and adapt to changing prey types highlights the complexity of evolutionary processes. As we uncover more about these ancient predators, we gain a deeper understanding of how life on Earth has evolved and adapted over millions of years. The legacy of the Madtsoiidae continues to inform our understanding of current biodiversity, and the fragility of ecosystems. Their enduring impact on our planet's history emphasizes the importance of paleontology in comprehending the intricate tapestry of life on Earth.